Hello everyone. This is the third part of the ANN workshop wherein we would look more into what backpropagation basically is. So before diving into the video's topic, let's first learn about what feed-forward neural networks are so that you could get a stronger basis of what the whole idea of backpropagation basically is, because they're related to each other. So feed-forward neural networks are artificial neural networks where the connections between the units do not form a cycle. Feed-forward neural networks were the first type of artificial neural networks invented and are very much simple. They are called feed-forward because information only travels forward in the network. There are no loops, just as the name says, forward. So first it goes through the input nodes, then through the hidden nodes if they are present, and finally through the output nodes. Feed-forward neural networks are primarily used for supervised learning, in cases where the data to be learned is neither sequential nor time-dependent. So supervised learning was a topic that was taught by Nick in the last workshop, I also gave a small recap of this topic in the first part of the video. So if you're still not clear on what supervised learning is, you can either pause this video and Google up what supervised learning is, or you can just take your time and go through the first workshop again and come back to this video. So getting back into this topic, a feed-forward neural network is a biologically inspired classification algorithm. It consists of a possibly large number of simple neuron-like processing units which are organized in layers. Every unit in a layer is connected with all the units in the previous layer. These connections are not all equal, some of them may have a different strength or a different weight. And these weights on these connections encode the knowledge of a network. And often these units in a neural network are also called as nodes. So data enters at the input layer, passes through the network layer by layer until it arrives at the output layer. So during the normal operation, that is when it acts as a classifier, there is no feedback between the layers, and that is why they are called as feed-forward neural networks. So if you look into the picture here, you would notice that it's a two-layer network with the output layer having 2 units, the hidden layer having 4 units, and the input layer having 3 units. Now, what is gradient descent? Gradient descent is an optimization algorithm. It's based on convex functions that tweaks its parameters iteratively to minimize a given function to its local minimum. You can also think of a gradient as the slope of a function. So the higher the gradient, the steeper the slope and the faster a model can learn. But if the slope is 0, the model stops learning. In mathematical terms, a gradient is a partial derivative with respect to its inputs. For example, imagine a blindfolded man who wants to climb to the top of a hill with the fewest steps along the way as possible. He might start climbing the hill by taking really big steps in the steepest direction, which he can do so as long as he is not close to the top. But as soon as he comes closer to the top, his steps will get smaller and smaller to avoid overshooting it. Instead of climbing up a hill, just think of gradient descent as hiking down to the bottom of a valley. Now, what's backpropagation? So deep learning systems are able to learn extremely complex patterns, and they accomplish this by adjusting their weights. So how are the weights of a deep neural network adjusted exactly? They are adjusted through a process called backpropagation. Without backpropagation, deep neural networks wouldn't be able to carry out tasks like recognizing images and interpreting natural language. Understanding how backpropagation works is very critical to understanding deep neural networks in general. So let's dive into what the whole idea, what the whole process of backpropagation basically is. So the process of backpropagation takes in the final decisions of a model's training, and then it determines the errors in these decisions. The errors are calculated by contrasting the outputs or the decisions of the network and the expected or desired outputs of the network. And once the errors in the network decisions have been calculated, this information is backpropagated through the network, and the parameters of the network are altered along the way. The method that is used to update the weight of the network is based on calculus, specifically based on the chain rule. In the first workshop on the 17th of September, we had mentioned that there are few basic prereqs we would want you to have. That is knowing a little bit of calculus, which involves knowing what chain rule is. So I'm hoping that you know what chain rule is and how this process would work around. So after the errors for the network have been calculated, the weights in the network must be updated. So as mentioned, calculating the error involves determining the slope of the output value. So once the slope has been calculated, gradient descent can be used to adjust the weights in the network. Let me explain to you what exactly the backpropagation algorithm is based on some visuals. So the input X arrives through a pre-connected path. The input is modeled using some real weights called W. The weights are usually randomly selected. Now we calculate the output for every neuron from the input layer to the hidden layer and then to the output layer. And to calculate the error in the output, it's usually a basic subtraction. So we calculate the actual output that was given to us by this network minus the desired output, the output that we actually wanted. So when you calculate the actual output minus the desired output, we get to know how much difference there has been, and accordingly it will travel back from the output layer to the hidden layer to adjust the weight such that the error is decreased, and then finally the new output that we get is similar to what the output we actually want. So why do we use backpropagation? There are various advantages of backpropagation. Few of them are as follows. Backpropagation is very fast, simple, and easy to program. It has no parameters to tune apart from the numbers of input. It is a flexible method as it does not require prior knowledge about the network. It is a standard method that generally works well, and it does not need any special mention of the features of the function to be learned. It just learns the very time you use backpropagation on the neural network. So you might all be confused, what's the difference between backprop and feedforward neural networks? Let me just give you a quick recap and differentiate both of them so the concept just gets more simpler for you. So a feedforward neural network is a type of neural network architecture where the connections are fed forward. They do not form cycles. The term feed forward is also used when you input something at the input layer and it travels from input to hidden and from hidden to the output layer. As mentioned, it is feed forward, so it goes in the forward direction. But the backpropagation is a training algorithm and it consists of two steps. So first it's fed forward, the values are fed forward, and then the error is calculated and it's propagated back to the earlier layers. So feed forward is in the forward direction and backpropagation is in the backward direction. So to be precise, feed forward is a part of the backpropagation algorithm, but it comes before backpropagating. But definitely all algorithms come with some disadvantages. And some of the most important disadvantages of using backpropagation is that the actual performance of backpropagation on a specific problem is dependent on the input data. So the input data can have a lot of errors. So backpropagation is very sensitive to noisy data, or data having a lot of errors, in other words. And backpropagation needs excessive time for training. So this is the end for this video, and the next video we would start our hands-on tutorial.